Welcome everyone to the only section of the week. Although you do have a very long exam, so I don't know how exciting this news is. We're going to be doing it a little differently here since it's kind of just one sort of two concepts for the whole section. We're just going to have one example problem per video this week. Okay, so you can kind of jump around and look at things more easily. You should be able to start after the first example, but the homework is really starting after the second example. So it's up to you. Do you want to start the homework after the first video or the second video? All right, so we got some long problems, and they're going to be optimization problems like the previous section, and then this new sort of inventory problem. Okay, so we're going to start with example 1, as we usually start. And this has a supermarket manager. This manager is anticipating that 1,200 cases of frozen orange juice are going to be sold. And specifically, they're going to be sold at a steady rate during the year. So we can assume that people are buying the same amount of frozen orange juice every single day. It's an assumption. It's not always going to be true, but it's an assumption, sure. And so the manager is going to plan on ordering these cases by placing equally spaced orders of the same size. And again, that makes sense if the demand is constant over here throughout the year. So given that it costs $8 to carry one case of orange juice for 1 year, we're going to find the carrying cost for the whole year, depending on some things. How much does it cost to hold this frozen orange juice? All right, and we're going to start with part A, where if the manager places only one order. So this is, the carrying cost is going to depend on how many orders the manager places, because if they place only one order, we're going to have that whole orange juice stock at the beginning. Whereas if we place 2 orders, we can kind of space it out. All right, so we need 1,200 cases. All right, so then that's one order, right? One order of 1,200 cases. And so you might think, okay, if it costs $8 to have an orange juice stored for the whole year, a case of orange juice, then we'll just multiply 8 times 1,200. But let's look at what's actually happening, because it's not quite that. So if you look at a graph here, and again, let's say this is 1,200 up here. We're ordering 1,200 at the beginning of the year. Let's say this is where 2022 starts. Let's not write that. Let's write this in months, okay? Then we start with 1,200. After 12 months, we've used all the 1,200, and the demand is constant. So this is what we look like in terms of how many cases of orange juice do we have in a given month. So it starts in January, and then it's going to end in December. So this is how many months have gone by. So what is the average here? The average, right, is going to be some amount right there. So at the beginning, we have 1,200. At the end, we have 0. So the average number of cases of orange juice that we're going to have in inventory is going to be 600. So on average, we'll have 600 cases throughout the year. So instead of being 1,200 times 8, because again, remember, $8 for one case for the whole year. So, if it is there the whole year, it'll be $8. But if it's only for half the year, it'd be $4. So we're just going to multiply it by the average number of cases we have stored. Okay, so the carrying cost is actually going to be 600 times this. Or again, this is the average. You can't see that, but I'm writing it. Average in inventory. And $8 is the annual cost per case. You really can't read that. All right, you just multiply these together and you should get $4,800. So if the manager only orders once in bulk, beginning of the year, January 1st, give me 1,200 cases of orange juice, then that's how much they're going to have to spend just storing the orange juice, 4,800. All right. Because on average, we'll have that 600. Now let's make the problem a little bit more complicated and kind of start generalizing to what's going on here. What if the manager places 2 orders? So if they placed 1 order, right, then they had to order 1,200. But if they're placing 2 orders, right, that's 2 orders of 600 each. So we have a slightly different situation over here in part B. Because now, again, we'll still be looking after 12 months. We're not ordering 1,200 anymore. We're ordering 600. We're ordering it twice. So the first 600, right, that's going to last the first 6 months. And then we order another 600, which is going to last the next 6 months. And now this is what our function looks like. So if we order twice, how many cases of orange juice do we average at any random month? What's the average number of cases of orange juice that we have? And again, it's just going to be half of what we're ordering. It's going to be 300. So now we average 300. So if we order twice, we actually only have to spend half the amount from if we order once. Now, later on in future examples, we'll talk about, this is for inventory costs. So the more orders we do, the less we have to have in inventory, right? So this is going to actually go down, right? The more and more orders we make, the lower the inventory costs we're going to do. But then we're also going to talk about ordering fees, where the more times you order, the more ordering fees you're going to have to place. So the problem is going to get more complicated, but this is just generalizing one part of that larger problem, inventory, okay? Inventory costs. All right, so let's generalize this in part C, shall we? What about if the manager places X orders? Now this is where things get interesting. So let's look at the previous ones. We need 1,200 cases of orange juice. 1,200 cases of orange juice. We'll average whatever half, right? We always average half of what we order. So if we ordered 1,200, we average 600. We're ordering 600 at a time, we're averaging 300. And then we have to order that 1,200. So if we order only once, it's going to have to be 1 order of 1,200. If we order twice, that'll be 2 orders of 600. Let's write that down. All right, we can do 1 order of 1,200, right? And then the average is going to be half that, 600. Or you can do 2 orders of 600, then you average 300. If we did 3 orders, well, then each one would have to be 400, because again, these have to multiply to 1,200. We need 1,200 throughout the year. And then we'll always average half of what we're ordering. So on 4 would be 300, average 150, and so on. So if we place X orders, what goes here? The number of orders times how many we're ordering needs to be 1,200. So X times what is going to be 1,200. Just divide both sides by X. And you get the answer to that what, right? X times what equals 1,200. Divide both sides by X. We'll get 1,200 divided by X. So it goes here. Right, and we can see that this formula works, right? If it was 1 order, 1,200 divided by 1. 2 orders, 1200 divided by 2. 3 orders, 1200 divided by 4. Divided by 3. 4 orders, 1200 divided by 4. X orders, 1200 divided by X. And the average that we have over here is always just half of this. So 1/2 of 1200 over X is 1200 over 2X, or we could simplify that a little bit as 600 divided by X. So what's our inventory cost? Our inventory cost is always the average in inventory, you can't quite see it, times the cost. All right, so that average is 600 over X times the cost. Whoa, that's not a multiplication sign, Jason. Times 8. The average, or the cost, will be 400 divided by X. So again, as we increase the number of orders, the inventory cost will go down. As X gets bigger, that fraction gets smaller. We're dividing by a bigger number. So if our true goal is to minimize our inventory cost, then we just order as many times throughout the year as we can. But again, there are reasons why we don't do that. Right? That's the first example. So if you want to try to start the homework problems, go for it. Otherwise, we're gonna look at some more complicated problems here.